All right, my friends. Hopefully, you've had a good couple of days since we've met. And once again, we're going to continue with our work on factoring. And today is probably the one of the easier days of factoring. And you'll see what I mean by that in just a moment. We're going to talk about something called factor by grouping. But before we get to factor by grouping, I want you to do our three warm up problems. All right, and this will cover all the factoring things that we have talked about so far. So go ahead and pause the video, attempt our three problems here at the top. Once you finish, turn the video back on and we will see how you did. All right, so hopefully you worked through these and starting to feel a little bit more comfortable with the operations of factoring. To save time, I've done the problems here on a separate sheet so that you can see those. All right. So now on our first problem, there was no GCF. So our A term is 5x squared. Our C term is negative 56. 5 times negative 56 gives us negative 280. So if you had a problem with these three examples, it was probably this one because there's a lot of choices to factor to find the factors of 280. So the right combination would be negative 35 times 80, which is negative 280. Negative 35x times positive 8x, or excuse me, negative 35x plus 8x is negative 27x. And you can see that I'm dropped the negative 35x in here. I've dropped the positive 8 in there. All right, and so, all right, now we can look for our GCF in our columns here. So we get a 1x for our GCF in the first column. Notice we get a negative 7. Both terms are negative in our second column. In our first row, the GCF would have been 5x. In our second row, it would have been 8. So in factored form, you should have ended up with x minus 7 times 5x plus 8. And I don't know if I've mentioned this before, but the order of these two factors does not matter. Okay, so if you have 5x plus 8 first and x minus 7 second, that's totally fine. It's just that you have to have those two factors. Once again, the order doesn't matter when you're multiplying, right? 2 times 3 is 6, 3 times 2 is 6. So whichever one you write first is not incorrect. It's the same thing up here. If you put the 8x in here and the negative 35x here in that box, your factors will change positions, but you'll end up with the same ones. All right, now moving on to our middle example here. Once again, no GCF. So we can jump our A term into the first box here, so 8x squared. Our C term into the last box here, which is a plus 5. A times C is 40. All right, and so that's a little bit of an easier combination to work with here. All right, and we know we have to get to negative 22. All right, so the two numbers that multiply to be a positive 40, negative 20 times negative 2, that also add to be negative 22. All right, I'm going to drop the negative 20 in here. I drop the negative 2 in here. And so when you look at that first column, that GCF is a positive 2x. All right, our GCF in the second column is a negative 5. Our GCF in our first row there is a 4x. And our GCF here in the last row is a negative 1. Now, once again, we talked about this before, that whenever our two terms here are both negatives, that means our GCF here and here have to be negative. All right, that way when we multiply to find the area of this region, it will give us a positive result. All right, moving on to our final warm-up problem here. This one does have a GCF. That GCF is a 3. So once I factor that 3 out, I'm left with 6x squared minus 11x minus 2. So my A term is 6x squared. My C term is negative 2. A times C is negative 12. All right, and this is a little bit of an easier combination. Negative 12 times 1 is negative 12. Negative 12x plus 1x is negative 11x. And so then if I drop the negative 12x in here, if I drop our 1x in here, we can now start looking for our GCFs. In our first column, it is 1x. In our second column, it is negative 2. In our first row, it is 6x. In our second row, it is positive 1. And once again, if we take that GCF out, we want to write it out front when we write our factors form. So 3x minus 2 times 6x plus 1. All right. So that is a review of all the factoring that we've talked about. Now, today, it's a little bit easier. So notice everything that we did the last couple of lessons were focused on trinomials. And once again, trinomials means that we have 3 terms here. All right, so you can see all 3 of our examples in the warm-up had 3 terms. All, except for one example in our last lesson, had 3 terms. What we're going to look at today is something called factor by grouping. Now, there's a dead giveaway with factor by grouping, and that is the number of terms. And so if you look at our first example here, we have 4 terms. And so notice this is the first time that we have seen 4 terms when we've been factoring. So that's a dead giveaway that we want to do factor by grouping. Now, here's why I mentioned earlier that this might be the easier or some of the easier problems, because we have 4 terms. Well, look at our area model. We have 4 boxes. So all we're going to do is drop each term into our boxes and then find our GCF. Now, once again, before I do that, we always want to see if we can pull a GCF out of the original problem before we start factoring with our area model. And in this case, in our problem here, we do not have a GCF. So what we want to do when we don't have a GCF is just take those 4 terms, and we're going to just put each one in our box. So x cubed here, negative 6x squared here. All right, 8x in this box, and negative 48 in this box. Now, once again, it doesn't really matter which box you put everything in. I just work in order going from right to left, all right, with the terms that I have here. And notice now every box is full. So this is easier than what we've actually done the last couple of days, because we don't have to find any combinations since there are 4 terms. They match all 4 boxes. And now we jump right into looking at each column and each row looking for that GCF. So when I look at my first column, all right, my GCF for 1 and 8 is just 1. My GCF for x cubed and x is just x. When I look at my second column, both things are negative, so I'm going to take out a negative. The GCF for 6 and 48 is, in fact, 6. All right, and then there's x squared here, no x's here, so I'm good there. Now, this is where it changes a little bit, because now we may not have a GCF that's just x. So when I look at my constants, I have 1 and negative 6, so my GCF would just be a 1. But my GCF for x cubed and x squared would be x squared. All right, now we look at my second column. My GCF for 8 and negative 48 would be a positive 8. And there's no x common to this term, so I don't have to worry about that. And we're done. It is really just that simple and that direct when we have those 4 terms. All right, so we have that 1x minus 6 for our first factor, and we have that 1x squared, okay, plus 8 for our second factor. All right, so go ahead and pause the video. I want you just to jump right in. All right, the second example here is very, very similar to the first example. So I want you to go ahead and just jump right in and attempt number 2 here, and then turn this back on and see how you do. Okay, so once again, first thing you should consider is, do I have a GCF? We do not. So then we can jump right into our area model. So once again, I'm just going to write in order here. So x cubed, all right, minus 7x squared, okay, plus 7x, and minus 49. All right, so there we go. All right, yeah, there we go. All right, so now if we look at our first row here, our GCF is just 1x. Once again, those two are both negative, so I'm going to take the negative out. The GCF for 7 and 49 is just 7. There's x's are not constant to both terms, so I don't have to worry about that. Now, when I move to my first row, my GCF would be 1, and then it would be x squared. My GCF here would just be a positive 7. All right, so now if we just write this in factor form, I'd have x minus 7, and I would have x squared plus 7. And once again, we've mentioned this a couple times already, but if you're ever unsure, all you have to do is take out a piece of scratch paper, all right, and take a look at these by doing your area model. And if you multiply everything out, combine like terms, you should be able to get what you started with, which is a nice self-check. All right, so moving on. All right, so let's take a look at number 3 up here. All right, now what you're going to notice about number 3 is when I look at all 4 terms, all right, there is a GCF. All right, so let's go with purple this time. I don't know, it feels kind of like a purple day here. All right, so when I look at 6, 2, 36, and 12, the one number I can divide all of them by is in fact 2. Now notice an x is not common to everything, so I don't have to worry about factoring out a variable. And so that would leave me with 3x squared and then this would just be plus 1x squared, and then plus 18x, and then plus 6. All right. So now, once again, we see that we have 4 terms. Really, really, really big hint that it's factored by grouping. So we just want to drop those 4 terms, all right, into our area model. All right, so I think I wrote a square here. Let's make that a cube. It should be a cube. Let's put a little curly on that one. Make it a 3. Let me erase this one. All right, let's get back to purple here. All right, maybe I've been watching a little bit too much Jessica Jones and the Purple Man. All right, so that should be a 3x cubed. All right, and then a positive x squared. And by the way, great series on Netflix if you're needing something to fill a little bit of extra time. All right, I would start with Daredevil season 1. All right, and kind of work up to Jessica Jones. It's a little bit connected, but there you go. All right, so plus 18x. All right, and then plus 6. I wouldn't worry about Iron Fist though. It's not very good. All right, so now looking at our GCF here, all right, we see that we'd have a 3 for our coefficients, and there's just an x. When we look at our GCF here, it's just a positive 1. Moving to our first row, it would be 1 for our coefficients, and then x squared for our variables. And maybe my pen will catch up here. There we go. And in our final row here, our second row here, our GCF would be a positive 6. Now, once again, we did take a GCF out at the beginning, so we want to include that when we write it in factored form. So 2, and then we have our 3x plus 1. And then we have our x squared plus 6. All right, so there we go. Now, once again, I'm going to let you do number 4. All right, so pause the video, give number 4 a shot, and then turn it back on, and we'll see how you do. All right, so did you catch that you do have a GCF in number 4? All right, it may not be as obvious because of the 84 here, but your GCF would be a 3. So hopefully you took a 3 out of this one, and that would leave us with a 9x cubed minus 12x squared plus 21x, and then minus 28. All right, so hopefully you caught that. All right, and found that 3 there. So now if we drop everything in, so 9 x cubed negative 12 x squared, and then we have our 21x and our negative 20. That's really bad. Pen is dragging. All right. Okay, go back here. We're on purple. All right, and so we have a negative 28. All right, and then hopefully you found that the GCF here was a 3x. The GCF in our next one would be a negative 4. Our GCF on our first row would be 3x squared. All right, and then our last one would be, all right, a positive 7. All right, so once again, make sure that you always keep that GCF out in front. So put that 3 there, 3x squared. All right, plus 7 and 3x minus 4, like so. So there's our factors. All right. And I think you guys are probably getting the hang of this. So here's what I want you to do. Pause the video, and I would like you to finish the rest of the examples on this page. There are 3 left. All right, so go ahead and work problems 5, 5, and 6. It should be 5, 6, and 7. But go ahead and give these 3 problems a shot. Pause the video and turn it back on. All right, so I'm going to work through, I had a kind of a change of plan as I was recording this. So I have the work for these 2 on the next slide, but I'll work through this one with you now. Once again, no GCF for this guy. All right, so we can jump right into our area model. So I'm just going to drop 12x cubed in here. All right, 21x squared here, 20x here, and 35 here. All right, and so then that's a really goofy looking 5. So let's try that one again. All right, and then, all right, so as you're looking at your GCFs here, there we go. All right, hopefully you found 4x here. All right, you hopefully found a positive 7 here, hopefully a positive 5 on this one. Oh, I skipped this one here, so we need a 3x squared here. So jumped ahead there. All right, and so hopefully you found that this in factored form would be 4x plus 7 and 3x squared plus 5. All right, so that's the factored form for this example 5. Now, the next two, I went ahead and did the work here, so I'll show those to you. Neither problem had a GCF, so you should have jumped right into your area model for both. All right, and if we look at our first column here, the GCF was 4x. Our second column would be negative 3. Our first row would have been 6x squared. Our second row would have been just positive 1. So then if you write it out in factored form, you should have one factor of 4x minus 3 and a second factor of 6x squared plus 1. Moving on to our final example for this lesson. All right, once again, no GCF, so I can drop all 4 terms into my area model. Our factor, our greatest common factor for our first column is 5x. Our greatest common factor for our second column is negative 8. For our first row here, you should have had 7x squared, and for our second row, you should have had a positive 2. So in factored form, you should have one factor of 5x minus 8. You should have one factor of 7x squared plus 2, and that is a wrap on our lesson on factor by grouping. So once again, Daredevil, really good. Iron Fist, not so much. So if you need something to watch, flip that on Netflix. It'll give you something to do in between all your factoring lessons and homework. I know you'll be wanting to think about math all the time, but it's good to turn your mind to other things. So give the homework a shot when you get a chance. Once again, log on, email us, sit in the Google Hangout. If you have questions, we look forward to talking to you. Hopefully you're all well and good, and we will see you soon.